This slide illustrates how to measure with a dry atmosphere in a glove bag. After installing the cell and stirrer in a glove bag, flow dry air into the bag. We do not recommend using dry nitrogen since there is a risk of suffocation. You may inject the sample with a glass sampler. Here you can see the Karl Fischer compartment inside the glove bag. Flow dry air and wait until the humidity reaches 20% or lower before placing the sample into the cell. Generally, volumetric titration is recommended for measuring solid samples directly in the cell, but if the moisture content is low and the sample can be dissolved in an anode solution, colorimetric titration can be used as well. Next, I will move on to discuss volumetric titration. This slide shows the volumetric titration apparatus, which consists of a main compartment and an automated burette. You can analyze high moisture samples and dirty samples with volumetric titration. Another advantage of this method is that you have a wide range of solvents to choose from, depending on the solubility of your samples. For solid samples, the most important thing is to select a solvent that dissolves the sample sufficiently. As well as in the colorimetric titration, I would recommend in the volumetric titration that you consider the absolute weight of the water of the measured sample in order to achieve accurate results. The ideal amounts of the sample water lie between 10 and 50 milligrams. This table illustrates, as reference, the preferable sample weights in contrast to their estimated water contents, which are calculated from this ideal amount range. The calculation is based on the usage of a titrant with a factor of 3 milligrams per milliliter. The following two slides illustrate examples of dehydrating solvents. Although the general use dehydrating solvent, GEX, is commonly used in volumetric titration, these two samples are measured with other solvents. Lactose, in the upper line, is measured with the dehydrating solvent for sugars, and margarine, in the lower line, is measured with the solvent for oils. I would like to remind you again that it is important to select a proper dehydrating solvent like this. Another example of the importance of solvent selection is related to liquid varnish with high viscosity. If you use dehydrating solvents that contain methanol to measure such varnish, some precipitates will form, and the detection electrode will be covered with them, disturbing normal measurement. The dehydrating solvent PE that dissolves such varnish plus SS as titrant is a good combination in these situations. It is important to consider which organic solvents can dissolve such samples prior to making measurements. Please refer to the brochure about the Karl Fischer reagents, since the main compositions are listed there. For the last topic, about volumetric titration, I will explain the lowest quantification level. To get reliable results with volumetric titration, the titration volume should be at least 50 microliters. When using a titrant with a factor of 3 milligrams per milliliter, 50 microliters of titrant is equivalent to 0.15 milligrams, or 150 micrograms, of water. If the sample size was 1 gram, this would mean that you can measure down to a concentration of 150 parts per million. For a sample size of 5 grams, it would be 30 parts per million. Theoretically, by using a titrant with a factor of 1 milligram per milliliter and a sample size of 5 grams, the minimum concentration can be brought down to 10 parts per million. But considering the difference in the solubility of samples and the risk of interference, etc., a realistic minimum concentration would be between 30 and 50 parts per million. This table shows the measured values of a low-moisture sample by volumetric and colorimetric methods. You can see that the averages of the results are similar for both volumetric and colorimetric titration, but RSD, or repeatability, is much better with the colorimetric method. This shows that the colorimetric method is more suitable for low-moisture samples. I would like to introduce several samplers that we provide for you to treat samples properly depending on their natures. First, when you measure solid or powder samples, you put the sample in the sampler as shown in the slide, then measure its weight and pour it through the sample injection port while turning the sampler upside down. It is convenient to use a spoon attached with a sealing plug if the sample is viscous, such as mayonnaise, for example. You can scoop up the sample with it and replace one of the stopper caps of the cell with it. Thus, the viscous sample can be immersed in the reagent while keeping the cell sealed. A glass rod with a spoon on one edge is used when you measure such viscous samples with a water vaporizer. You can scoop up the sample with it and insert the whole sampler into the boat of the water vaporizer.